Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at solving logarithmic equations. So let's go ahead and get started. Now, there's several things I have to review before I actually talk about how to solve logarithmic equations. So first of all, we know we have our pattern here for dealing with logarithms when you want to go from exponential form to logarithmic form and vice versa. So you got y equals log base a x, and when we want exponential form is x equals a to the y, like that. And so these two things are equivalent forms, and like I told you before, it could be a little confusing about where to put things. So when you're trying to convert back and forth, you have to just label them and then move them accordingly as you get comfortable with how to do it. Now there's two other things I need to talk about. Now, again, but before I move on, this is going to be very, very important when we start dealing with our equations, because sometimes we have to convert things to different forms. Now, having said that, there's something else I need to talk about, and there are two very common logarithmic functions. One of those is called the natural logarithmic function, which is basically when you have y equals ln to the x. And so when we say ln to the x, we're talking about the base, if you will, is going to be Euler's number. That's the famous letter E, which stands for like 2.71 or something like that. And essentially what ln x means is you could put it like this: log base E x. That's technically how it works out. But because it's natural in terms of it's found in nature, I guess, if that's how you want to say it, we often just use the ln instead, which stands for natural logarithm. So this is what we use right here, and you can see that. The other one is the common logarithmic function, and that is where essentially you have y equals log base 10 to whatever x you have right there. Now, because we use the we use a decimal system, this 10 is so common that it's usually not written, and so you just have like this. A logarithm always has to have a base. And so if the base is 10, we don't write it. The only time we write the base, of course, is when the base is not 10, as in this example right here, however you want to put it. So we have the natural logarithm and we have the common logarithm, and these are things that you're going to commonly encounter when you're trying to solve logarithmic equations. And also, don't forget our important information right here at the top, this guy right here. So having said that, let's go ahead and look at our first example. So let me just go ahead and rewrite this. Y equals log subbase a x, and then x equals a to the y power, like that. So here's our first example. We're going to have log subbase a 121 equals 2. So this is what we have. And now what we want to do now is, it's not possible with the skills we have to solve this in the current form here. However, if we change this to exponential form, we can definitely solve it. So with that knowledge, we just look at what we have here. So we got, this is going to be the a, and this is going to be the x, and this is the y. So with that knowledge, we just write it over here appropriately. So the x is going to be 121 equals a, and then the y is to the second power. So what I did was I converted this from logarithmic form to exponential form. And so now, because we're familiar with radicals, we can solve this. So I simply do the following. All I have to do now is I square root both sides. And I end up with the square root of 121 is 11. And the square root of a squared is a. And that's my answer. So in other words, if I wanted to write this in logarithmic form, I would say log base 11, 121 equals 2. That's what I would put, just like so. And you can rewrite that. But you can see how by knowing the different forms, you can now solve things accordingly. So let's do another one. Example 2 here. Now with this example, we're going to deal with the natural logarithm. So again, when we're talking about the natural logarithm, we're talking about ln, whatever it is, base x, or not base x, but to x. All right, like this. So again, another way of writing this is you put log base Euler x, like so. These are equivalent expressions. but you don't use this one. So here we go. So we got natural logarithm x equals 7. All right. So again, what can we do? Well, remember our pattern here at the top. So y equals log sub base ax, and then we also have x equals a y to the y power. Now, here's the thing. When you're a beginner, I would say it's better to put the natural logarithm in using the regular logarithm with the Euler as the base, because then you can just follow the steps that you're familiar with. Again, this is only for beginners. So what I would do first is I would rewrite this where it'd be log base e with the x here equals 7. Now, once it's written like this, I can follow my patterns here at the top. Again, this is only until you start to get comfortable with how to do this. So let's see here. The e is going to be my a. The x is going to be, well, you know, my x. And then the 7 is going to be my y. So understanding that, so x is going to be x equals, the a is going to be e to the 7th power, like that. And you can see that we're already done. This is the answer because we've already solved for x. So another way to write this is that we could write it logarithm is e to the 7 equals 7, and that kind of makes sense because this is the same as raising it to the first power if you're more familiar with exponents. So that's kind of what's happening there, because when you take the logarithm of 1 to the 1, it's just natural logarithm with the Euler is just 1, and that's what's happening there. So you can see that, you know, this is working out appropriately. Let's do the next one. So in this next one, we're going to have a slightly different base. So let me first rewrite our little cheat code here at the top. Log sub base ax, and then we have x equals a to the y, like so. So here's our example here. We got log base 2 with the 5x minus 1. No, that's not very clear. Equals 6. All right. So let's take a look at this. The 2 is my a. So this is my a. This 5x minus 1 is my x, and the 6 is my y. So if I rewrite this, let's see here. X is going to be 5x minus 1, that's my x, equals, my a is going to be 2, and then my y is going to be 6. All right, so now I need to figure out what 2 to the 6th power is. That's going to be 64. So if I rewrite this, I have 5x minus 1 equals 64. And now it's just basic algebra. Plus 1, plus 1. So now I got 5x equals 65. Divide by 5, divide by 5. And then you can see that x is going to equal 13. So that's what's happening in that particular example. And then you can check these, of course, if you really desire to. And so, again, but that makes sense because if 5 times 13 is going to be 65, 65 minus 1 is going to be 64. All right. And then we know that 2 to the 6th power equals 64. We got the information right here. So we know that that's correct. Let's do our last example. So this time we're using the natural logarithm again, but let me put my little cheat code at the top here just for reference sake. Y equals log sub base x, and then x equals a to the y power. All right, now here's our example. The natural logarithm of e to the 3x equals 6. Okay, again, we keep things simple. We just, now again, if you're more familiar with math, you can already see the answer, and I'm going to show you the shortcut in a moment, but let's just solve this the long way first. So I will rewrite this as log base e with e to the 3x, like so, equals 6. All right, so let's see what we got here. So this e right here is going to be my a, and then this guy, this e right here is going to be my x, and then this guy right here is going to be my y. So therefore, if I do that, so x is going to be e to the 3x equals, let's see here, a is e to the 6, like so. Now here's the thing, we already did a video on dealing with exponentials. When they have the same base, you can ignore the basis and just solve the exponents. So that means that we now have 3x equals 6, divide by 3, and x equals 2. Now, for the A students, you already knew the answer immediately, because when you have the natural logarithm and then you have this inside the parentheses immediately, these cancel out right here to become 1. And so you immediately have 3x equals 6. I mean, that's immediate. However, I wanted to go through all the steps to show you how to do these things appropriately. But as you get more comfortable with how to deal with these, you can start taking these little shortcuts and solve things much faster. But the goal here is not speed. The goal here is to develop familiarity with the concepts. So having said that, I want to go over what we did, and then I will conclude the video. So in this video, we talked about how to solve logarithmic equations. And so we began by, of course, talking about the form, going from logarithmic form to exponential form right here. And then I exposed you to the natural logarithm, which is just log with the base of Euler. And then also the common logarithmic function, and that's where you have log base 10. It's so common that you don't even put the 10 most of the time. And also with the natural logarithm, you put the ln instead of the log. That's one of the main differences there. We then began going through how to solve equations that involve logarithmic functions. So our first example here was a log base a. And so if you just convert it from logarithmic form to exponential form, it's just algebra after that, not too deep. And with this example, we had the natural logarithm. And so again, as you get comfortable with this, but at first I converted it to the logarithmic, the regular logarithmic form right here for the purposes of solving it. And by going through all the steps, you get the answer. It's not that deep. And so for this one right here, we had a log that was a base 2 rather than a base 10 or a natural logarithm. But the process still applies. What's also new here is that we had all this stuff going on inside the equation. But again, once you simplify things, it's just algebra anyway. It's not that hard. And so that's what happened there. In this last one, we were using a natural logarithm again. But again, I converted it first to just, the common logarithmic form, with the base of Euler. And then we just solved it accordingly and completed the answer. Of course, there was a shortcut here. The natural logarithm of Euler is going to be 1 because they kind of work together. And so that cancels out, and you just have the 3x there, and then you can just solve accordingly. Either way would have worked. It just all depends on, what you're trying to do here. So my name is Darren Thomas. I'm the Director of Educational Research Techniques. Thank you for watching. Take care.